All right, welcome to another adventure in old code. Today we're going to have a look at something called Letfind. Let us find out together what this is. Actually, I have my suspicions about this one. I do seem to recall something in the deep recesses of my mind. Perfect. Okay, let's begin this adventure. What word? Yeah, I do totally remember this. So, what word would you like me to search for? Let's look for zebra. Enter. I don't remember this. That's hilarious. The reason why this is hilarious is there's actually a built-in function in QBasic that will count the number of letters in a string. And since I just supplied a word, I should be able to figure out how many letters is in that word. But apparently I did not. So, okay. I did not know how to use that. Okay, well, there are 5 letters in zebra. And I should have chosen something a lot smaller. Now, what's going on here? Yeah, that'll never end. Oh, no. Okay. Let's go back. I gotta choose something smaller. Let's find. Okay, let's look for eat. How many letters in word? There are 3 letters in the word eat. You may be asking, what the heck is it searching? It's not actually searching. From what I recall, I generated random words of the length that you supplied and just checked if it equaled that word. So there's literally 26 cubed possibilities at this point, and it's going to check. And it's not even going to check them all. It's just randomly checking. So clearly 3 letters is too much, and I have no way of exiting that out, so we're gonna... Okay, I have a new, better idea. Let's search for the word two. There are 2 letters in two. Oh, come on. There we go. Perfect. Right after New York. I see New Zealand in there. I see the element zinc. Oh, there are all sorts of fun stuff in there. Okay, so it found 2 and it kicks you out of the program. Oh, it took 2,019 times to get 2. Go again? No. I said no. Okay, let's look for the word I. There's only 1 letter in I. Did it just totally find it right away? That's awesome. Go again. No. Maybe it's only looking for 1 character. No. Okay, there we go. All right. Let's see what's going on here. Oh, and it just starts out with a do right away. Okay. So, do, words. This is a variable. And it's being set to 0. We're clearing the screen. What word? And that goes into word 1 string. Okay. How many letters in word? And that goes into letters. Then I take the word that you've supplied and I uppercase it, because I'm not going to check even more combinations of uppercase and lowercase. And then I do. This is a nested do. A do inside a do. So Now once we have the word and the number of letters, so for the word, for instance, zebra, it had 5 letters. It picks 5 random letters. The way it does that is it randomizes the timer, which I keep stating. And clearly my previous self is not getting the hint. Apparently my messages aren't traveling back in time like 2 decades. I did not need to randomize the timer at any point except the beginning of the program. It doesn't hurt it. It just doesn't have to be done. Okay, so I'm basically picking a random number right on this next line here. Picking a random number between 1 and 26, and then I'm adding 65 to it. And actually, if I wanted between 1 and 26, in all of my other programs, I would have a +1. This gives you a 1 to 26. Because if the random R&D is a decimal value between 0 and 1, so if after it picks the random number and then multiplies it by 26, it truncates off all the decimals, and you're left with an integer between 0 and 25, and that's why everything has a +1 in all my other programs. This time, instead of adding 1, I'm adding 65. And this is so I get a random number between 65 and 90, I guess. Will that do it? Yeah, that should do it. And because those are the ASCII codes for the uppercase letters from capital A to capital Z. And then I'm generating that random number, and then I'm printing the CHR string. So I'm converting it to an ASCII character and printing that on the screen. If letters equals 1, so if my... Interesting. I have no idea. If letters equals 1, so if this is the first letter of the word, then word toString equals CHR string. Oh. Okay, so that's why I have a word 1, because there's a word 2. So word 1 is the actual word that you typed in at the beginning. Word 2 is the random word, and we're going to build it up. So if this is your first letter of the random word, then you're going to set word 2 just to be that letter. Otherwise, you're going to append the new random letter to the end of that random letter. Okay, that's... Yeah, I see. I think it would have been cleaner if I would have just said word toString is empty. No, that would have had to be up here. Yeah, it would have been cleaner if I said word toString is an empty string here, and then I wouldn't have had to do this or this or this or this, and just whatever it was, append it to the end. If it's the first one, that's okay. It's the first one. It used to be empty and now it's 1, so that's okay. I don't even know if I would have had to append it. Maybe I would have had to, or not append it, but actually initialize it. Well, when you have a question, why don't you just try it out? So let me get back to regular state here. My assumption is, now can I cut text? Just cut it all out. Word toString equals word toString plus CHR string of X. Now, does that work? I want to look for the word I again. It's got one letter. Boom. Took 19 times. No. So yes, that would have definitely worked. I'm just going to open it up again. So that would have worked, but I thought maybe that wouldn't have worked. So anyway, that generates your random word. And then, okay, words is just the number of guesses that you've tried so far. So add 1 to words after you guessed your word, after you've generated your word, excuse me. And just do a check. If word toString is not equals to word oneString, then word toString equals empty string. I set it to empty string right there. Perfect. And just keep looping until word oneString is equal to word toString. That's not very complicated at all. It doesn't have to be. Press any key to continue. Wait for a key press. Clear the screen. Tell me how many times it took to guess the word. Go again. Loop until you say N. Not no, N. That's it. Okay, well, I feel one of the things that is very interesting about old computers, and it still is the case today, we just don't notice it very much because we don't do a lot of printing into the screen. But printing the text takes so much time. And I will demonstrate that to you now, and hopefully I don't make a fool of myself. So remember how it was taking a long time to find the word eat? Or two. It took 2019 times to get two. We were waiting for a bit. Eat, it just couldn't. We were waiting too long. So I'm going to get rid of printing the character on the screen. This is the only point where I actually print anything onto the screen. I do it here as well. This print statement is empty because I'm going through and I'm generating a random character, printing, 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 all in the same line. And then when the word is finished, I do an empty print to go to the next line. So we'll comment that out as well. Without any print statements, I am going to assume I can find the word eat with 3 letters. Go. And we wait. It should take 26 times more guesses than it took to find the word to, but it should not take 26 times the amount of seconds because I'm not printing to the screen. But gosh, somewhere there is another program that I wrote that will come across eventually. I was going to say that does find words more efficiently, because I remember finding my name and all sorts of things. This just stopped. Nice. It took 35,627 times to get eat. Right, and it just stopped because I wasn't printing anything to the screen. So that actually was hardly, I mean, what? How long was that? 40 seconds? Whereas before, we were waiting for the word to come up, and it took about at least 15 seconds just to get 2,000 guesses. So I think this demonstrates that printing to the screen takes a lot of time. So go again, definitely not. All right, have a nice day. We'll see you next time for more adventures in old code.